Hey y'all. So we are still working on 12.1. Remember I said there was 3 power rules. So we've done the rule where we have a base inside of parentheses being raised to a power, then on the outside of the parentheses being raised to another power. So when you had a power to a power, we multiplied the powers. Then the other rule was whenever we had multiple different bases inside of parentheses, and that set of parentheses was being raised to a power. And so whatever we had inside of the parentheses also gets raised to the power. So even if you had an A, B, C, D, everything will get raised to a power. You just have to remember that that does not count for whenever you're doing sums. If you have any kind of operation, a positive or a negative inside of the parentheses, then the exponent actually, this rule wouldn't count. So what we're going to do now is that third power rule, if this wants to cooperate. No, just kidding. Yes, maybe. Okay, we're going to do this third power rule right here. Let me hide that. And this one, it's going to be in a quotient type of form, like a fractional value. It's still in a set of parentheses, but what you have is an A over B. So all this says is you have 2 different terms. That's why it's with 2 different letters. If it was an A over A, that would be saying that you have the same values on top and on the bottom, like in your numerator and in your denominator. This is saying you've got something in a numerator and something else in the denominator. And then right there, we're going to have an M, which means it's being raised to an exponent. So really similar to the previous one that we had done, if you have a problem that looks like that right there, what happens is your term in your numerator and your term in the denominator, they would both get raised to that power. So what we're going to do is an example here. For the first example, I'm going to use actual numerical values. I'm going to show it to you in exponential form, and then we could actually solve it, evaluate it. And then I'm going to show you an example using just variables. So this first one, let's say if in parentheses, and then in a fraction form, we have 5 over 3. Close your parentheses, say it's being squared. It's being raised to the second power. If you look at the right-hand side of the equal sign, that told me that both the top and the bottom get raised to that power. It doesn't matter if you have 4 things in your numerator and 6 things in your denominator. All 4 in the top and all 6 in the bottom, they're all going to get raised to that power. So this is just a really general rule, and it only shows you 1 in the top and 1 in the bottom. But just know that it could actually be applied to anything in the top and anything in the bottom. So because this is being squared, what you do is you actually square what's in the numerator. So that would be 5 squared over, and then you square what's in the denominator. So that would be 3 squared. So once you actually square the top and the bottom, if you notice, it's not all still in parentheses and all being raised to an exponent, right? Because I'm applying that rule. So if your homework or if an exam tells you to evaluate this, but leave it in what would actually say to simplify. If it told you to simplify this, but leave it in exponential form, this would be your answer, because the numerator is in exponential form, meaning you have a base and an exponent, and the denominator is in exponential form, meaning you have a base and an exponent. Now, if a problem says to actually evaluate it, then that's when you look. If you have 5 squared, y'all, that's 5 times 5, right? 5 times 5 would be 25. They're both positive, so my product would be positive. And then in that denominator, we have 3 squared. Well, 3 squared is 3 times 3, which would be 9. At any point when doing a problem like this, you would always want to look to see if there's common factors. Can it be reduced? Here, the 25 and the 9 actually don't share a common factor. So this would be considered your fully simplified, evaluated answer. Okay, so I want to do a problem that I'm going to have my work. I want to do a problem where instead of numerical values, what we just have is variables. Oh, let me add this, y'all. I didn't, and it is very important. I don't see them giving this to you in the homework, and I wouldn't try to trick you in an exam or anything, but this whole rule right here is with us assuming that our b, whatever's in the denominator is what that means. Whatever we have in the denominator does not equal 0, because we all know, like, the whole world blows up if you try to divide by 0, right? It's all fun and games until you attempt that. So that's just like a little like added thing just to be technical. Okay, if you don't understand the homework and you look at the help, you'll see it say that, and that's what it means. And we're good because 9 does not equal 0, so we're okay. Now if you do an example that just has variables in parentheses, say you have m over n. All this means is just that you have two completely different bases, one on the top, one on the bottom, two completely different variables. Again, you could have 5 up top, but this homework gets crazy. Okay, like, I'm not kidding. Wait till you do it. You'll see it's not going to be every problem as simple as this with just one term on top and one term on the bottom. If you do see something like that, you still use the same thing and you still solve it the same way. There's just a few extra added steps because you have a few extra added terms. But if you follow that rule, it told me that my numerator will get that power. So now it's m to the 4th, and my denominator also gets that power. So in the bottom, we have n to the 4th. That would be the simplified answer for this problem, because we actually don't have a rule that we could apply here, since we have different variables. Like, they're not the same bases. M and M are not the same. So this would be the answer to a problem using this rule. Okay, so I'm going to do another video in a minute, and we're going to actually combine some rules together so you can see something that's a little bit more closely related to the difficulty that you'll come across in the homework. So if y'all have questions, make sure you ask, okay? Bye. Just kidding. There we go. Okay, now bye.